Alright folks, today we are on the last lesson of Unit 4, 410, proving statements about triangles. Take the next 3 minutes, silent solo, to complete the think about it in your notebook. Go ahead and get started. Alright, so here's how I started out the think about it. I annotated the diagram with all the information that I knew to be true. I knew that I had a given side and a given angle that were congruent to a side and an angle in the other triangle. And I also knew that line segment CA was congruent to itself by the reflexive property of congruence. So based on the congruence postulates that I learned this week, I know that these two triangles are going to be congruent by SAS. I have an included angle here, and so I can prove the triangle is congruent that way. So from there, if I know that the two triangles are congruent by SAS, it means that the triangles are going to have the same size and shape. Remember, the definition of congruent that we use in geometry is two figures are congruent if they have the same size and shape. So if they are going to have the same size and shape, then the corresponding parts of those two triangles are also going to have the same size and shape, meaning they're going to be congruent. So it follows logically then that if these two triangles are congruent, BC will also be congruent to DC because they are corresponding parts, and corresponding parts are congruent. So this leads us to our first key point of today, which is that if we need to find out whether corresponding parts of triangles are congruent to one another, we first need to show that the triangles are congruent, and then we can show that the corresponding parts are congruent. This first key point leads us almost directly to our big idea for today. And our big idea for today is just alphabet soup. It is CPCTC, which stands for corresponding parts of congruent triangles are congruent. That is our big idea for today, is that corresponding parts of congruent triangles are congruent. So to connect the key point and the big idea, if we have two triangles and we can prove them congruent, then we can prove that the corresponding parts of these congruent triangles are always going to be congruent to one another. CPCTC is an incredibly powerful tool that we will use not only in this unit, but also throughout future units to prove various geometric theorems to be true. So take a look at the first I&M question. So these triangles should look familiar. We've done different proofs with these same triangles. We have given information, but this time, rather than being asked to prove that triangles are congruent, we're asked to prove that AC is congruent to BD. We're asked to prove that corresponding parts of congruent triangles are congruent. So, to use our first key point for the day, before we can prove the corresponding parts congruent, we have to prove the triangles congruent. And as I've said to you many times before we can start proving triangles congruent, we must annotate our diagram with all of the given information. Since these two triangles are overlapping, I would start by redrawing them and then annotating accordingly. Take the next 1 minute on your own to redraw and annotate these triangles with all of the known and extrapolated information. Go ahead. So here were my annotations on this first diagram. I annotated both on my original and also on my redrawn triangles, so you can see that I have my two given angles. Be careful with your annotations of your angles. Make sure you have the right little skinny ones annotated. And then a shared side at CD. You can see this more easily down in my redrawn diagram. So I just wrote a little note to myself to help me keep things straight that ACD is going to ultimately be congruent to BDC by AAS. Go ahead and write a proof up to proving the triangles congruent for these two triangles. Take the next 2 minutes to do that on your own. So here's my proof of all of the information that I annotated in this diagram up to proving the triangle's congruent. But remember, in this proof, we were not asked to prove the triangle's congruent, we were asked to prove corresponding parts congruent. So as our key point told us, once we have proved the triangle's congruent, we're allowed to prove corresponding parts are congruent by CPC-TC. Corresponding parts of congruent triangles are congruent. And you can write that out either as a complete statement, as I have, or you can also just write CPC-TC. Just like the congruence postulates are allowed to be abbreviated, you can also abbreviate CPC-TC, and that is understood to mean corresponding parts of congruent triangles are congruent. So here is your complete proof for the first question. Please make sure to make your notes match this exemplar if you do not have the exemplar already written. Okay, let's try another one of these. Here is I&M example number 2. Very similar setup to last time. We have some given information, and again, we're asked to prove that corresponding parts of the triangles are congruent. To lock back in the key point, before we can prove corresponding parts congruent, we have to prove the triangles congruent. Before we can prove the triangles congruent, we must annotate our diagram. Take the next 1 minute, silent solo, to annotate your diagram. Here is my annotated diagram. I marked up the definition of midpoint twice here because I knew that T was the midpoint both of SV and of RU. So notice that I have two different sets of congruence marks here, and then I have a set of vertical angles. I found it helpful to redraw my triangles to make sure I was lining up the corresponding parts in the right place. This was a rotation that took place to map one shape onto the other, so I find it helpful in a rotation to redraw the triangle. So when I did that, I can see that RTS will be congruent to UTV by SAS. I have two sides and an included angle here. Now that you've gone through the whole process of proving corresponding parts of congruent triangles congruent in example 1, take the next 2 minutes on your own to write a full 2-column proof that proves that RS is congruent to UV. Go ahead on your own in your note. Here's my exemplar proof. I have my givens listed out. Notice that I listed definition of midpoint only one time and put both pieces of information under the same statement. That is fine, or you can separate it out. I have my vertical angles. Triangles are congruent by SAS, and notice that I just went straight to the abbreviation here of CPC-TC. That's fine. Please add anything that you did not have to your work in your grading pen.